The first question of the pre-lab asks to make truth tables for each output of the circuit. So you can see that this corresponds to that gate, this corresponds to this one, this corresponds to the second AND gate, and then this corresponds to the Z output gate. And then we go to the second question, where I made these circuits in Circuit Lab, but for the interest of time, to make this video short, I've compiled the answers to a Word document. So if you can pause it, all the ones that are vertically aligned have the same circuit, but I just changed that up, inputs to be different so that you can see the different results. I did the same thing with question 3 of the pre-lab, this time using, of course, not and or gates. And again, I compiled all of those into one Word document. Again, you can pause and slow down to see what I actually did. For the fourth part of the pre-lab, you can see I've made the 2-to-1 multiplexer in Tinkercad, and I apologize for it looking like this. This is my first time using Tinkercad, but input B is going to be blue, green is going to be the selector, and input A is going to be yellow. Right now both yellow and blue are off and green is on, so if we can turn that on, you can see that the bulb does not light up. However, if we stop that and we move this to be on, so A is on and B is off and yellow is on, that should also not light up. And then if we turn all of them on, it should light up. And one more time, if we have the selector on, that we put input B off, it should again still light up. Okay, for question 5 of the pre-lab, as the hint suggested, I used 2 multiplexers for the top and 1 for the bottom to get the 4-to-1 multiplexer. The reason that this works is that S0 is being compared to all 4 inputs, and then again S1 is being compared to all 4 of them, while S0 is also considered to get the final output. As you can see, I've made the circuit in real life. This is the NOT gate, this is the AND gate, which is being used at both sides for both AND gates in the circuit, and then this is the OR gate. And as you can see, these 3 are the inputs, with the green being the selector. If I input this here and move it around while the other 2 are on, there is no change to my circuit. If we make it so that one of them is on and one of them is off, you can see that this does actually have an effect when the selector changes spots. For the final part of my lab, I have this code, which I believe is right, and the same circuit. I have these 2 plugged into pin 4 and pin 8. However, for whatever reason, I can move these around and nothing happens. I have tried troubleshooting for a while and it doesn't seem to be working. You can see that it's lighting up slightly when I put the selector into ground, but that's about it.